We're going to take a look at graphing rational functions, not irrational ones, rational. So they always think logically. So a rational function basically has variables in the bottom. It may or may not have variables in the top. Technically, it's a polynomial over a polynomial. We have variables in the top, variables in the bottom, no fractional exponents, so it's a polynomial over a polynomial. Same idea over here. So when we take a look at this one here, we graph it, we're going to have issues with both of these whenever the bottom is 0, because we cannot divide by 0. So on this one over here, what causes the bottom to be 0 is x being 2, negative 2. So we end up having a vertical asymptote, a vertical line that your graph gets close to right here, but never really crosses. Over here, we don't have a vertical asymptote at x equals negative 2, but we still have a problem at x equals negative 2 because it's what causes the bottom to be 0. We actually have a hole in our graph. When you're dealing with rational functions, you're either going to have vertical asymptotes or you're going to have holes showing up. So what's the difference? Well, the one here on the right, we did not have any common things top and bottom, no common variables top and bottom. So whatever causes the bottom to be 0 ends up being that vertical asymptote. So you set the bottom equal to 0, you solve it, you get x be negative 2. In this case, you also happen to have a horizontal asymptote, a horizontal line that your graph gets close to but never really crosses, and that's y equals 0. Over here on the left, it kind of looks like a straight line just with a hole in it. Well, if you factor the top is really differences of squares, x plus 2, x minus 2. You'll notice that x plus 2 shows up top and bottom. That's your common factor. So you look at what causes that common factor to be 0, and that's negative 2. So you're going to have a hole in your graph at negative 2. Now, when you cross these out, what are you left with? Well, you're just left with that x minus 2. Well, when you graph x minus 2, you know that that's just a line, slope of 1, y-intercept of negative 2. So you just graph that diagonal line. But we know it's going to be undefined right here on our graph when x is negative 2. By the way, to find out the y-coordinate of this, all you have to do is take that whole number, which is negative 2, plug it into the simplified function. So after you've crossed stuff out, plug it into what's left. What was left was an x minus 2. We plug in that negative 2, we get a negative 2 minus 2, so our hole has the coordinates of negative 2, comma, negative 4. And you'll notice that's where it shows up on our graph. Now, a hole is technically referred to as a point of discontinuity, which occurs when there's a common factor top and bottom. To figure out the y-coordinate of that hole, you take what causes that common factor to be 0 and plug it back into the simplified function. A vertical asymptote occurs when the simplified function still has variables in the bottom, and that what causes that to be 0. Horizontal asymptotes are what happens, or what your graph approaches as you go far to the right and far to the left. So common features of rational functions are vertical asymptotes and holes and horizontal asymptotes. A rational function does not have to have all of them. It will sometimes only have a few of them or one of them. So let's take a look at this here. We want to first of all start off by finding our vertical asymptotes and holes. So to do that, you need to factor the top and the bottom. Factor the top, differences of squares, factor the bottom. You'll notice we have a common factor here, top and bottom. So we're going to have a hole at what causes that common factor of x plus 2 to be 0. So you set x plus 2 equal to 0, you solve it, and you have a hole at x equals negative 2. So then you look at what's left. What's left are just the first two factors. By the way, your hole's at x minus 2. To figure out the y-coordinate of that hole, take negative 2 and plug it into the simplified version, and that's the y-coordinate of your hole. you'll notice we still have we'll have a vertical asymptote here because we still have variables left in the bottom. What causes the bottom to be 0 is your vertical asymptote. So you're going to say x equals -3 is your vertical asymptote. So that's how you go about finding holes and any vertical asymptotes. This one here, factor the top, factor the bottom. Notice we have a common factor. If you don't have a common factor, that means you don't have holes. But in this case, we do. What causes that common factor to be 0, which is a -3? So you have a hole, x equals -3. Now, to figure out the y-coordinate of that hole, take -3 and plug it into the simplified version, and you get a -6 over a2. Now, you'll notice we also still have variables left in the bottom of the simplified version. So we'd have vertical asymptotes. That's what causes the bottom to be 0. So set the bottom equal to 0, solve it, and you get x to be -5.